In the world of consumer electronics, this controller is a relic, a piece of plastic designed for leisure. But in June 2023, this device became the visual shorthand for a catastrophe that captivated the world. The deep ocean is not a playground. It is a hostile, high-pressure environment where physics demands absolute perfection. At 3,800 meters down, the pressure is approximately 380 atmospheres, or about 6,000 pounds per square inch. It is a realm where the difference between life and death is measured in millimeters of material thickness. The Submersible Titan was marketed as a revolution, a vessel born from the ideology of Silicon Valley. Move fast and break things. But maritime engineering is governed by a different rule. Regulations are written in blood. This is not merely the story of an accident. It is a forensic timeline of a collision between hubris and the immutable laws of thermodynamics. It is the story of how 5 people were lost to a catastrophic failure of a pressure boundary that, according to established maritime science, should never have been built. To understand the failure of June 18, 2023, we must look back a decade. OceanGate, founded in 2009 by 2 founders, was led by CEO Stockton Rush, sought to democratize deep-sea exploration. Their initial vessel, Cyclops 1, was a steel-hulled refit. It was robust, proven, and limited to shallow depths. But Rush's ambition lay much deeper. He wanted the Titanic. Deep-sea engineering has a gold standard: the sphere. Geometrically, a sphere distributes pressure perfectly evenly across its surface. It is the shape adopted by the Alvin, the Mir, and the limiting factor. However, a sphere is cramped. It limits passenger capacity and, by extension, ticket sales. To fit 5 people, a pilot and 4 mission specialists, OceanGate needed a cylinder. But at extreme depths, cylinders suffer from uneven stress distribution. To counter this, traditional engineering demands heavy titanium or high-yield steel. Rush, however, wanted the vessel to be neutrally buoyant and easy to launch. He turned to a material unproven for deep-sea compression: carbon fiber. Carbon fiber is a miracle material in aerospace, where it excels at handling tension, being pulled apart. But a submersible hull is under compression, being crushed inward. Using carbon fiber for a pressure vessel at 4,000 meters was not just unconventional. It was an experimental deviation from all classification society standards. The warning signs were not subtle. In 2018, OceanGate's Director of Marine Operations, David Lockridge, authored a scathing report. He identified a critical flaw: the inability to non-destructively test the carbon fiber hull for delamination, the microscopic separation of layers deep within the material. Lockridge argued that without these tests, the hull was a ticking clock. He refused to sign off on manned tests. In response, he was fired. Soon after, a letter from the Marine Technology Society, signed by dozens of industry experts, warned Rush that his experimental approach could result in a catastrophe. Rush dismissed these concerns as industry gatekeeping, stating that classing is not sufficient to ensure safety. Investigations revealed that the carbon fiber used for the hull was reportedly sourced from expired aerospace stock, material that had exceeded its shelf life for airplane use. OceanGate was betting lives on the assumption that what wasn't good enough for the sky was somehow sufficient for the crushing depths of the abyss. June 2023. The support vessel Polar Prince departs St. John's. The atmosphere on board is a mix of high-stakes adventure and casual tourism. This was not a military operation. It was a commercial transaction. 5 souls prepared to board the Titan. Hamish Harding, a British aviation tycoon and seasoned explorer who had previously visited the Mariana Trench. Shahzada Dawood, a prominent Pakistani businessman, and his 19-year-old son Suleiman. Reports suggest Suleiman was hesitant, joining the expedition primarily to please his father over Father's Day weekend. Paul-Henri Nargeolet, known as Mr. Titanic, a veteran French diver with over 30 dives to the wreck. His presence lent the operation a veneer of legitimacy. Why a man of his experience trusted the experimental hull remains one of the tragedy's most haunting questions. And finally, Stockton Rush, the architect of the vessel and the pilot for this mission. The boarding process itself highlighted the vessel's unsettling design. The forward dome was secured with 18 bolts from the outside. The crew entered, and the titanium end cap was closed behind them. 17 bolts were fastened from the outside. Once that final bolt was turned, the occupants were sealed within a pressure boundary they had no control over. Regardless of what happened, fire, medical emergency, or panic, there was no exit without external assistance. They were effectively bolted into a tomb before they even hit the water. Sunday, June 18th, 9 a.m. local time. The Titan slips beneath the waves. The descent to the Titanic takes roughly 2.5 hours. Inside the pressure hull, the temperature drops rapidly. The only light comes from the screens and the single viewport in the bathroom area. Communication with the surface is maintained via text messages sent through an acoustic modem. There is no GPS underwater. The pilot relies on text instructions from the polar prints to navigate. For the first 90 minutes, the logs, released during the 2024 Marine Board of Investigation hearings, show a routine descent. All systems nominal. Approximately 1 hour 30 minutes into the descent. Depth, around 3,300 meters. The pressure is now exceeding 330 atmospheres. The carbon fiber hull is compressing, shrinking by fractions of an inch. This is the hysteresis effect, the material straining under the load. Suddenly, the Titan's proprietary real-time health monitoring system, the RTM, detects an anomaly. This system was designed to listen for the acoustic signature of cracking fibers. Rush had claimed this system would give the pilot enough warning to arrest the descent and surface. Evidence suggests the acoustic sensors began registering a crescendo of micro-failures. The hull was speaking. 10:47 a.m. The Titan drops its ballast weights. This is an emergency procedure to increase buoyancy and slow the descent. A final text message is sent to the polar prints. Drop 2 WDS. Drop 2 weights. This confirms that the crew was aware of a problem. They were attempting to abort the dive. Approximately 1 hour 45 minutes into the descent, telemetry is lost. The acoustic link goes dead. On the surface, the polar print sends a query. No response. They wait. In deep-sea ops, communication dropouts are common. They wait for a scheduled check-in that never comes. When the Titan failed to resurface at its scheduled time of 3 p.m., the clock began ticking on a massive international search and rescue operation. The U.S. Coast Guard, Canadian Coast Guard, and private vessels mobilized. The narrative gripped the world. 5 people, trapped in a minivan-sized tube, with 96 hours of oxygen. But this narrative contained a fatal flaw. It assumed the pressure boundary was intact. The search covered thousands of square miles. Sonar buoys were dropped, listening for any sign of life. Then came the banging noises. On day 2, sonar buoys detected rhythmic sounds, reportedly in 30-minute intervals. The media seized on this as evidence of human intelligence, survivors tapping on the hull, adhering to SOS protocols. It was a moment of profound hope for the families. However, subsequent analysis by the Navy and Coast Guard debunked this. The ocean is a noisy place. The sounds were consistent with biological noise, whales, or the mechanical clatter of the search vessels themselves. The 30-minute interval was a pattern imposed by human bias, seeking order in the chaos. There was no one tapping. The silence had been absolute since Sunday morning. Thursday, June 22nd. The oxygen clock had theoretically run out. The ROV Odysseus 6K reached the seafloor, 3,800 meters down. Within hours, the cameras picked up an unnatural shape in the silt. The debris was about 500 meters from the Titanic bow. It was the tail cone of the Titan. Crucially, the pressure hull was missing. The debris field contained the titanium end caps, the landing frame, and fragments of the carbon fiber shell. This pattern confirmed the worst-case scenario. a catastrophic structural failure. We must pause here to understand the physics of this event. When the pressure boundary failed, the external water pressure, roughly 6,000 psi, rushed in. The collapse of the hull happened in less than 1 millisecond. To put that in perspective, the human brain requires approximately 13 milliseconds to process visual information. The spinal cord requires even longer to register pain. The air inside was compressed adiabatically, generating extreme heat for a fraction of a second. For the 5 men on board, there was no drowning. There was no suffering. Their existence ended before their nervous systems could even transmit the signal that something was wrong. It was a mercy of physics in an otherwise merciless event. The recovery of the biological evidence and the wreckage marked the beginning of a forensic deep dive. The 2024 Marine Board of Investigation hearings laid bare the engineering realities that OceanGate had obscured. The primary culprit was inadequate engineering leading to delamination and buckling. Unlike steel or titanium, which can endure repeated pressure cycles if they stay within their elastic limit, carbon fiber composites degrade. Every time the Titan dived, the hull was compressed. When it surfaced, it expanded. This cycle caused micro-buckling in the epoxy matrix, holding the fibers together. With each dive, the hull became weaker. Testimony revealed that on previous dives, the pilot and passengers had heard loud cracking or gunshot-like sounds. Rush dismissed these as the hull settling. In reality, these were likely the sounds of irreversible structural damage, delamination. Furthermore, the interface between the titanium rings and the carbon fiber tube was bonded with a specific industrial glue. The MBI investigation highlighted that the different expansion rates of titanium and carbon fiber created shear stress at this bond. Water intrusion at this seam may have initiated the collapse. The investigation concluded that the Titan was not failed by a single mistake, but by a cascade of negligence. The refusal to class the vessel, the reliance on acoustic monitoring instead of physical testing, and the dismissal of cyclic fatigue data created a probability of failure that approached 100%. This tragedy forces us to confront uncomfortable questions about the nature of innovation. Stockton Rush often quoted General MacArthur, "You are remembered for the rules you break." He believed that safety regulations were stifling progress, mere red tape preventing humanity from accessing the deep ocean. But in maritime history, regulations aren't red tape. They are written in blood. Every line in the SLAS, Safety of Life at Sea, convention exists because a ship sank and people died. OceanGate attempted to bypass these lessons with a liability waiver. So, I want to ask you, where do we draw the line between being a visionary and being negligent? Did the passengers, Hamish, Paul-Henri, Shatsada, and Suleiman, truly understand the waiver they signed? Or were they blinded by the marketing of a company that conflated experimental with cutting edge? There is a difference between taking a calculated risk and taking a blind gamble. The Titan was not testing a new technology. It was ignoring established science. And in the end, the ocean does not care about your mission statement. OceanGate has suspended all operations. The Titan is gone. But on the ocean floor, amidst the rusticness of the Titanic, there is now a new debris field. Two tragedies now rest within sight of one another. One caused by the hubris of the Gilded Age, believing a ship was unsinkable. The other caused by the hubris of the Silicon Age, believing physics could be disrupted like a taxi industry. We remember the lives lost to the deep. Hamish Harding, Shatsada Dawood, Suleiman Dawood, Paul-Henri Nargeolet, Stockton Rush. Thanks for watching. Stay safe and see you next time.